Heidi ho there, Geometry Biorino. Right, so we're moving on to our second unit, which is all about similarity. So we're not going to jump too much into actual similarity and geometry and everything until after we get back from break. What we're going to do for now is we're going to focus on ratios and proportions, which are a pretty big part of similarity. So first things first is, what the heck is a ratio? All right, so a ratio, all it really is it's a comparison of two quantities using division. Right, so we're going to take a look at a couple real life examples here to figure out how we use ratios. But if you're somebody that's really into baking or cooking in general, you might say oh, if you want to do this recipe, your flour to water ratio needs to be 2 to 1 or something like that. Right? It's basically just a way to relate quantities. So one real life situation is when you're talking about teacher to student ratio at a school. All right, so at Logan's High School, there are 190 teachers and 2,650 students. We want to figure out the approximate student to teacher ratio at his school. All right, so the wording of it does make a difference, right? Student to teacher ratio, right? It kind of has a direction to it. So because it's student to teacher, what we're going to do is we're going to take that student number, 2,650 of you folks, 2,650 students, and we're going to divide it by the number of teachers. Oh wait, hold on. I misspelled that a little bit. 190 super cool people. All right, cool. Yep, so we have 2,650 students and 190 super cool people. So when we do this out, right, all we're doing is we're simplifying this fraction. 2,650 divided by 190. It's not quite exactly this, but we're just going to kind of roll with it. It's about the same thing as 14 over 1, right? You could have just 14 as your answer. So what that means is that there's a 14 to 1 ratio of students to teachers, right? So when we're trying to write this as a ratio, what we can do is we can write it out kind of like this. It's 14 to 1. Right, so this is really what you're going to see when we're talking about ratios. Right? 14 to 1 is the ratio. It's for every 14 students, there is one teacher. Right, another place that they use these is in baseball. Right, so in baseball, a player's batting average is a ratio of the number of hits to the number of at-bats. And so again, right off the bat, it's kind of giving us a direction as to how to look at this. It's the number of hits to the number of at-bats. All right, so now whatever number I have for hits is going to go on top, and the number of at-bats is going to go on the bottom of the fraction. In 2018, Mookie Betts, oh my God, used to be on the Red Sox, awful, terrible team. So glad they moved to the Dodgers. Mookie Betts had the highest batting average in the league. By the way, go Yankees. He had 520 at-bats and 180 hits. So to find his batting average, like I was saying, that little piece I have highlighted is going to help us figure that out. It's the number of hits to the number of at-bats. So the 180 hits is going to go on top, and then we're dividing that by the 520 at-bats. Right? So when we do this one out, right, we could just end up with a fraction. Right? It's going to actually come out a little bit better as a decimal. It's usually how you see batting averages. So we get 0.346. You might be thinking to yourself, Mr. Pog, you're amazing. You did 180 divided by 520 in your head? Well, you're welcome to keep on thinking that, but I have the notes already all done out. So, if you want to just pretend that I didn't just say that and keep thinking that I'm super good at division in my head, go for it. So what this is doing is this is telling me that his batting average is 0.346. Right? So this is another way that we can kind of represent a ratio, right, is with a decimal. If I wanted to kind of convert this into something that was a ratio, what I could do is I could, just pretend that I'm moving the decimal place, right? 0.346 is the same thing as 346 out of 1,000. Right, so if you're somebody that's into baseball, whenever they're saying oh, they're batting 500 or you're batting 1,000, right? That's really what's going on. It's saying that for every, in this case, 346 hits, that means that he must have been at bat 1,000 times, right? So sometimes it can be nice to have things as a decimal because it portrays the same information as a fraction or a ratio would. Right? So what we're going to kind of jump into are these things called extended ratios. Right? So that's when we've got, more, like 3 or more things that we want to compare all at the same time. And we're going to jump into what it's going to look like for triangles. So we've got a triangle here, right? The ratio of the measures of the angles in this triangle ABC, which I guess we could put ABC on there. ABC is 3 to 4 to 5. Right, so you notice that inside the triangle, it's got these little markings that are 3x, 4x, and 5x. Right, what that's doing is that's telling me what the ratio is. Right, it's some amount of 3 to 4 to 5. That's how those quantities relate to each other. But the thing that they kind of relate around is what we don't know. Right, so that's why we have to put the x in there. If I was asked to find the measures of these angles, what I can do is I can say, all right, I got a triangle. I know that all the angles in a triangle add up to 180 degrees. So what I could do is I could say that, all right, 3x plus 4x plus 5x is going to equal 180 degrees. Right? Nothing too super fancy. Right? We're just kind of going through like we normally would. Right? I have all these angles, they add up to 180, let's figure it out. So 3x plus 4x plus 5x over there all smushes together to give 12x. Right? Then to get that x by itself, we have to divide everything on each side by 12. All right, when I do that, I'm going to find out that my x is 15. All right, so this is pretty big. We haven't quite finished the problem yet, right? It wants us to actually find the measures of the angles. So what I need to do now is I need to take that 15 and plug it into each one of those. All right, so for this one up here, this is going to be 3x. So 3 times 15 is 45. So we'll get 45 degrees there. For this one down here, 4x, 4 times 15, is going to be 60. So 60 degrees. So last one down by C, it's going to be, again, we're plugging in that 15 for the x. So 5 times 15 is going to give me 75 degrees. All right. Hopefully it doesn't seem so bad, right? We just kind of started off, all the angles add up to 180. Do a little bit of algebra out, and then we plugged it in. That's all that's really going on here. If we ever have something like number 14, right, it doesn't give us the image that it showed us for number 3, right? Oh gosh, holy moly. So in this one, in a triangle, the ratio of the measures of the sides of the triangle is 3 to 3 to 8. So if the perimeter of the triangle is 392, what are the lengths of the sides? So let's go ahead and let's draw in a quick little triangle here, right? In geometry, a diagram is something that might be pretty helpful. All right, so let's say that I had something like, oops, nice, look at that, perfect, first try. So if we had 3 to 3 to 8, right, so just like the last one, we don't know quite what it is that they're all relating around, so that's where we're going to put an x in. So I'm going to say that this side is 3x. I could say that the other side is 3x. This big long side is 8x. All right, so that kind of gives me a little bit of a baseline on how to think through the problem. If I know that the perimeter of the triangle is 392, well, how do you do? I know that the perimeter is what you get when you add up all the sides. So I'm going to do 3x plus 3x plus 8x, and that'll equal 392. Not too shabby. All right, so again, all I'm going to do is over on the left, I can smush all of those together. Right? 3 plus 3 plus 8 is going to give me 14x's all together. After that, I need to just divide everything by 14 in order to get rid of that coefficient and get that x by itself. And what we're going to find is that x is equal to 28. But again, just like before, we're not 100% done yet. What I need to do is I need to take that 28, plug it back in so I can actually find the lengths of the sides. So those sides that were 3x, let's give ourselves a little divider there. Those sides that were 3x, well, now what we're doing is we're going to plug in a 28 for those. Right? So 3x is now 3 times 28. 3 times 28 is going to give us 84. All right, so we're going to have two sides that are 84. Right? If you could do that again, you could say, like, oh, this one's also 84. And then the last one was 8x. So it's going to be 8 times 28 when we plug that in, which comes out to be 224. All right? So a way that you could always go back and check your work is, we just figured out what we think the side lengths are, right? 84, 84, and 224. If I add all those up, that should hopefully give me the parameter that they were talking about. Right? If they don't, then that must mean that I made a mistake. Right? So it's never a bad idea to go back and check with that. Right? But if it all works out, you're good to go. Right? So something else we might do with ratios is we might be able to do some stuff with proportions. Right? So a proportion is basically when you take some ratios and you put them into an equation with each other. So what we're going to have is we're going to have a situation that might look something like this. Right, we're just going to use some variables. We got A divided by B is equal to C divided by D. Right, so again, remember that ratios are just fractions. Right? That's really what's going on there. Whoops. Right, so when I'm going ahead and setting this up, I'm saying that these two ratios are equal to each other. What we do is we have some special names for them. We have the extremes, which are A and D. We have the means, which are B and C. Right? Calling them extremes and means is not really, you're not going to need to remember exactly, oh, these are the extremes. Like, you're not going to need to pick them out. But it's helpful for us to be able to talk about them, right, when we're doing these next couple things. So when we've got a proportion, we've got our extremes, we've got our means, what we can do is we can take the cross products. Right? So what that means is that we are taking the products of the extremes, A and D, and then we're also taking the product of the means, B and C. Right? So it kind of forms a little X there. Right? That's why they call it the cross products. Right? So remember, the product just means we're multiplying. So it's A times D and B times C. Right? We have this thing called the cross product property, which is basically saying that when I do this cross product thing, A times D is going to be equal to B times C. Right? The red stuff and the blue stuff are going to be equal to each other. Right? So, I know this is probably one of those things where you're looking at definitions and you might be like, oh my gosh, what the heck is going on with this? It's a little bit easier when we get into the problems. Right? So we've got this proportion here, right? And what it's telling me to solve it, right? What that means is that I need to go ahead and do those cross products, set them equal, and then figure out what's missing, right? In this case, I need to figure out what X is. So what I'm going to do is I'm going to go ahead and I'm going to figure out what my cross products are going to have to be. Right, so I'm going to have 6 times 31.5, and then the other one, oops, the tablet's kind of slowing down, is X times 21. I know that might be a little bit hard to see what's going on here. How about let's try this instead. Let's do like that. So X times 21, right, is just 21X. Oops. So 21X is something that we're going to be able to set equal to the other cross product, which is 6 times 31.5. Right? So this is like the hard part, right? After we get this set up, it's just a regular algebra problem, right? So I'm going to kind of work my way through this, right? We got 21x. 6 times 31.5 is 189. Right? And then one step left. I just got to get rid of that coefficient, right? I got to get rid of the 21. So we'll divide that on both sides. We'll find that x is just 9. And that's it, right? So set up the equation with the cross products, set them equal to each other, and then you just got an algebra problem, right? That's really all that's going on. All right, let's try another one out. Gross. This one already looks worse. Mr. Pog, why do you do this to us? This is awful. All right. So what we're going to do is we're going to kind of start it the same way. Right? I have 2 times 4x. Right? 2 times 4x is just going to give me 8x. Right? You're welcome to write it out as its own step, right? 2 times 4x in parentheses. Right? But if you can do it in your head, it saves you a little bit of writing. For the other cross product, I've got x plus 3 times 5. So when you're setting these up, there is sometimes a little bit easier of a way to write them out. Right? In this case, I'm going to put that 5 out in front of some parentheses with x plus 3 in them. Right? Then we can just go ahead and we can distribute the 5 like we would normally see it. Right? Cool. So I've got 8x over here. Like I said, I'm just going to distribute that 5 on into those parentheses. Right? So we'll get 5x plus 15. Right? What I need to do from here is I'm going to need to move all my x's over to one side, and I want to get them away from the other numbers. So I'm going to move that 5x over to live with the 8. And so 3x equals 15. Chop them both by 3. And then we'll get that x is equal to 5. Right? So some of these do have a couple extra steps to them. Hopefully they don't seem super duper bad though. Right? Just set them up equal, solve it out like you would normally. All right. Oof. So something to be careful with on this one, right? You see that there's that subtraction sign in front of 4/7, right? So what I usually like to do is I like to kind of include it with part of the top, right? So I'm going to think about that as a -4 when I'm going through this. Right? So if I'm setting up my cross products, I'm grabbing these things. Right? So 7 times 6 in the blue, it's going to give me 42 for those. What I'm going to do is I'm going to set that equal to that -4 times 2x plus 5. Right? So just like on the last one, I'm going to take that -4 and I'm going to distribute it into those parentheses. Right? So I'm going to get 42 equals, it's going to be -8x minus 20. Okay? In this case, all the x's are already on their own side, right? We have all -8x's over on the right. What I then need to do is I need to move all the other numbers to the left side, right? Get those away from that. So I'm going to add 20, move that on over. So get that 62 is equal to -8x. And holy moly, we were so close to having a nice even numbered problem. So what I need to do is I need to divide everything by -8. Alright. So when I go ahead and do that, it's not going to come out too pretty. We're going to get -7.75 is equal to x. Right. Once we get there, it's really all we got to do. Right? You can use a calculator on any of these that you need to, right? That's not going to hurt anything. And in fact, it's probably better for something like 62 divided by -8. Okay. But again, same kind of deal. Right. If you haven't paused and tried one on your own yet, I might suggest trying this one out. Right? It's pretty similar to what we were doing, just with a little bit of extra distribution there. Right, what I'm going to do is I'm going to kind of run through this one, maybe a little on the faster side. And I've got my cross product set to go. So I've got 9 times x minus 1. And I'm setting that equal to 7 times x plus 4. Okay. So on each side, I'm just going to do out the distribution, right? On the left here, that's going to be 9x minus 9. On the right, we'll get 7x plus 28. All right, so now what I'm going to do is I'm going to move all my x's and numbers to their own sides, right? I'm going to take those 7x's, I'm going to move them over to the left. And so what we'll get there is 2x minus 9 equals 28. I then need to move that 9 over to the right, Get it away from the x's. So I get that 2x is equal to 37. And gross, it's not going to come out too nicely again, but that's all right. We'll divide everything by 2. And what we get is we're going to find that x is equal to 18.5. Right. Hopefully not too bad. And again, calculator is going to be your friend on some of these, because some of the answers don't come out too nice. Alright, next one up here, right, same kind of deal. I'm going to run through, I'm going to grab my cross products, I'm going to set them equal and kind of run from there. So in the blue I've got 2 times that 3x minus 10. I can set that equal to, whoops, preferably not with pink highlighter. I can set that equal to 7 times x minus 7. Okay. So, again, distribution on each side. Distributing that 2 in for the blue gives me 6x minus 20. On the right, we're going to get 7x minus 49. I don't know how many of you guys have ever tried to write something and also say what you're writing at the same time, but it's sometimes pretty difficult. Oh man, getting a real workout with it. So, what we're doing is I need to move all my x's over to be in one place, just like before. And so I'm going to have -20 equals 1x minus 49. I need to move that 49 over away from where the x's are. And so what we're going to get is 29 is equal to a single x, which we can just write as x. Right, which means we're done. We don't even have to divide on this one. Sweet. Could have been worse. Okay. Oh boy. So we do have some word problems, right? If you're watching this part, it means that your teacher has decided that the word problems are something that's still good to know about, right? So on this first one, Tom conducted a survey of 50 students who drive to school. He found that 28 of them owned their own car. if 755 total students drive to school, we want to try and figure out how many students own their own car. Right? So what we're going to do is we're going to set up a proportion to figure this out. So Tom conducted a survey of 50 students and found that 28 of them owned their own car. Right? So if I was trying to think about how to set that up as a fraction, right, that's 28 out of the 50 of them owned their own car, so 28 over 50. What we're trying to do is we're trying to also predict how many students own their own car out of the 755 of them that drive to school. Right, so I don't know if you picked up on it, but I just said out of the 755. So that means that I'm going to put some number out of 755. What's that number? We don't know yet. So what I'm going to do is I'm going to use a variable. I'm just going to call it x. So the way that we're going to do this is we're trying to basically say that, oh, that survey is about equal to what it's going to be for the entire school. Right? So what we're going to do is we're going to put an equal sign there. Right? That's going to let us set up our cross products just like we were doing on those other problems. We got 28 and 775. We got 50 and x that we can multiply, right? So setting up the cross products just like we did before. So 50 times x is just 50x. On the other side of the equal sign, we've got 28 times 775. Yuck. All right, so again, calculator's your friend here. 28 times 775 is 21,140. Gross. Then we need to divide it by 50. Oh boy. So we're going to get is that x is equal to 422.8. So when you're doing problems that involve real-world situations like these ones, right, whenever you end up with a decimal, it's going to be a really good idea to round your answer, right? Because if I'm trying to say how many students own their own car, it's like, oh yeah, I just went out to the parking lot. I saw 422.8 people that owned their own car. That doesn't make any sense. You can't have 0.8 of a person. It doesn't work that way. Right? So what we're going to do is we're going to round to the nearest number. Right? So I'm going to round it off to 423 students. Right? If it was 422.1, right, I'd probably round down to just 422. Right? So rounding it off is going to be a good idea because then you're talking about an actual number of people. Right? Let's try another one out. One day, Brady netted butterflies and tagged them. Ugh, sends a shiver down my spine. I really hate moths and butterflies. A week later, he went out and netted 48 butterflies. Ugh. Only 3 of the butterflies he netted had a tag on them. We want to predict how many butterflies would be tagged if he netted 100 butterflies. All right, so again, we're going to kind of figure this out. So Brady netted 3 butterflies with a tag out of the 48 that he grabbed. Right, so that's 3 out of 48. Right? We're trying to figure out how many he'd get if he netted 100. Right? So some number would have tags out of 100 if he grabbed that many. Right? And again, we're going to set these equal because we're going to assume that the ratio would stay the same between these two situations. Right? So again, I'm setting up my cross products, going through it same old way. So 48 times x is just 48x. On the other side of an equal sign there, we've got 3 times 100, which is a solid 300. Right? Again, if you can do the multiplication in your head and save yourself an extra step of writing, never a bad thing, right? But be careful if you are doing that. Make sure it's coming out right. So next, all I got to do is just divide by 48. So 300 divided by 48 is not only going to be gross, it's also going to be 6.25. Right? So again, on this one, right, we're trying to figure out how many butterflies would be tagged if he netted 100 of them. You can't really have 0.25 of a butterfly, at least not in any sort of nice way that we want to talk about butterflies in. And so instead of calling it 6.25, let's just call it 6 that will have tags. Right? That's what we're expecting he would catch if he caught 100. Right, last one here. Julia's baking muffins. Oh man, much better than moths and butterflies. Her recipe calls for 2 eggs per dozen muffins. She needs to make 108 muffins, and we want to figure out how many eggs she's going to need. Right, so 2 eggs per dozen muffins. Right, so 2 eggs for every dozen. And if you didn't know, a dozen is 12. A baker's dozen is 13 because you know, the baker's got to taste test it, of course, right? So you make one extra. So 2 eggs per dozen. She needs to make 108 muffins. We want to figure out how many eggs are going to have to go into that 108. Right? It's the same old deal. Right? We can set up our proportions here, figure out what our cross products are. 12 times x is 12x. On the other side of things, we're going to have 2 times 108. Right? When I go ahead and I simplify that side, 2 times 108 is 216. And then it's just a matter of dividing to get that x by itself. Right? So last but not least, we're going to get that x is equal to 18 eggs in order to make 108 muffins. Wow, it's quite a lot of eggs. Can you imagine just putting 18 eggs in a bowl? Anyway, I'm going to stop talking before I get too off topic and drag this out for another 15 minutes, because I'm sure that's what you would all hate to listen to. All right, so be sure to check on Google Classroom for anything else that you got to do this week, and I am out of here.